everyone. Today is another episode of chemistry course on Global Education Zone, and today I'll be talking to us on electricity and chemicals. Now, electricity and chemicals, they are very important. They are two different things that when they overlap, they produce something very strange, something very interesting. And so that's what we're here to discuss today. And that interesting thing we're talking about here is nothing other than electrolysis and electrochemical series. So let's dive into electrolysis and the ionic theory and all the rest. So now electrolysis basically is the process by which a chemical compound, when you pass an electric current through a chemical compound, through a solution, and that chemical compound is known as an electrolyte. So when you pass electricity through that electrolyte, it decomposes. That electrolyte breaks down. So it is when that electrolyte breaks down, it allows the ions to flow freely. So those ions flow freely, and the charges carried by those ions complete the circuit of that electricity. So now for those of you who don't know the basics of electricity, let me explain that electricity, for electricity to flow, you need to have what's known as a circuit. So and then when you have a circuit like this, a circuit is basically a closed loop. So and then when you have your terminals, the terminals of your electricity, for example, you have a battery. When you connect your battery, assuming this is the battery here, this is the positive and this is the negative. So more about that soon. So this battery, whenever it's connected to your solution, then this is the solution. Yeah. So and this solution consists of a chemical compound, and this chemical compound is known as an electrolyte. Now these terminals, they are called the electrodes, and these electrodes, they are divided into cathode and anode. Now your cathode is the electrode from which your chemical, or rather your electrical current, leaves your circuit. So and your cathode is a negative electrode. Then you have your anode. Your anode is the positive electrode through which your electrical current enters the circuit. So now, if this is our this will be our positive, this will be our negative, right? Now this, electrons move from negative to positive, but conventional current moves the other way around. So now when we move from here to here, this electrode from which the electrons enters the solution is known as the anode. So it enters from here. This is really the anode, this will be our positive electrode, and then this one will be our negative electrode, the cathode, from which the electrons leave the circuit. Now in this case, whenever this battery is connected, when we remove it from the solution, there's no flow of electric current. For example, if we put a filament bulb here, for example, put a filament bulb and then try, when we remove it from the solution, it won't light. But when you put back into solution, you notice that this actually light. The reason is that whenever you put something like this up, the circuit is completed. For electrons to flow, they have to go around, let's like a circle. They have to go from their starting point and then come back to their starting point. And in doing so, they perform electrical work. Now this electricity is performing an electrical work in this solution, because as it flows from the negative to positive, and it's flowing from the anode to the cathode through this solution, it is decomposing this solution. It is breaking down into its ions, and this solution, some of these ions are being deposited. Now that is basically the crux. That's basically the whole theory of electrolysis. What I've explained now is just the basics, and that is the whole basics. Now moving further, we have what's called an electrolyte, and your electrolyte is that chemical you are decomposing. Then your electrodes are your anodes and cathodes, which are your positive and your negative electrodes respectively. Then we also have your battery, your wires, and all the rest. So for this kind of setup, it's called an electrolysis. This is an electrolytic setup, and this is the use of electricity to break down a compound. So and then we have to talk about now these compounds are broken down. There are different factors. When these compounds are broken down, sometimes they become deposited. For example, the positive ions can be deposited in the cathode, then negative in the anode. So there are reasons for that. Now there are different factors that affect the deposition. For example, if we have two different ions in this solution, for example, maybe we have this is a solution of copper tetraoxide 6 CuSO4. Then this solution, the compounds here are copper tetrahydrosulfate 6, and because that copper tetrahydrosulfate 6 is dissolved in water, this solution will also involve water, H2O. So those are the two compounds. So, and when electricity passes through this solution, this mixture of two compounds, it will break them down. So it will break the CuS4 into copper 2 plus, copper 2 positive um, 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 ion. It will break the tetrahydrosulfate 6 ion into SO4 minus, SO4 2 minus. Then the H2O itself is broken down into hydrogen ion and hydroxide anion. Now these ones, you can see that we have four ions: copper cation, tetrahydrosulfate 6 anion, hydrogen cation, and hydroxide anion. Now the fact is that in electrolysis there's kind of a survival of the fittest. So not all these ions can be deposited in the deposited out of solution. So there has to be some that picks, and there are three factors that affect it. For example, we have the position on the electrochemical series. Now let me explain that. Now these elements, every element and every element and every radical we have in chemistry, they are ranked according to their reactivity, according to their electrochemical activity. That means how easily it is to make them lose electrons, or how easy it is to make them partake in reactions. Now, for example, in the electrochemical series, copper is just a little bit higher than hydrogen. Then this tetrahydrosulfate 6 ion, it is higher than hydroxide ion. So now what that means is that the elements that are lower in the electrochemical series will be deposited. So because this tetrahydrosulfate 6 is higher than the hydroxide ion, and this hydroxide ion is lower than tetrahydrosulfate 6 ion, so this tetrahydrosulfate 6 ion will be favorably deposited. So, and what that means is that this anion, the anions will go to the anode and the cations will go to the cathode. So don't forget that. So, and when this OH goes to the anode, it goes here at OH minus. Then this for the copper and the hydrogen, because the hydrogen is lower in the electrochemical series, it will be deposited at the cathode. So that will be H positive. So that's an example of what happens in an electrochemical process. So next, let's go on to the second property, the second feature affecting this. We have concentration, the concentration of the concentration of the ion. Now, for example, if the ion is highly concentrated in solution, it will be deposited. Now, and for this question, which I said for this copper and hydrogen, actually hydrogen is above copper in the electrochemical series, so copper will be the one deposited here. That's hydrogen, Cu2 plus. So the lower the element or the radical, the more chance it has to be deposited. Now we have concentration. Now if the concentration of an ion or an element in a solution is greater than the concentration of the ion with which is competing with, for example, if the solution of CuS4 is so concentrated, so then we have that definitely copper will be deposited. And let me note that in electrolysis there's no it is not in black and white, because for example, at times a little bit of the weaker concentrated element or radical can get deposited. That is, it still gets deposited, but not as much as the one that has a higher concentration. So it is not in black and white, there are still gray areas. Now moving on, another property that affects the rate at which a substance is deposited is the nature of the electrodes. Now these electrodes, they are the terminals, right, through which electricity enters and leaves the solution. Now this electrode, whenever the element or the material used to make them can react with the ions, so any ions can react with it, that ion will be favorably deposited. For example, if we use mercury containing electrodes containing mercury, so and mercury reacts with sodium to form sodium amalgam. So whenever you have mercury in your electrodes, that mercury will attract the sodium. So, and that sodium, even if that sodium is not supposed to be deposited, it will be favorably deposited because of the presence of mercury. So that is an example of how the effect of electrodes can affect your product in electrolysis. Moving on, we have what we call laws of electrolysis, and there are two basic laws of electrolysis. Now these laws, they have their statements, and you are going to use their statements to do the calculation. The first law of electrolysis states that the mass of an element or the ions in an electrolyte, that mass of the element that is deposited after the electrolytic process, that mass is proportional to the quantity of electricity that is passing through the electrolyte. So what that means is that now that mass will be in grams, obviously. Then that quantity of electricity is basically in coulombs. The unit of quantity of electricity in coulomb. Now that coulomb means that whenever you have 1 coulomb of electricity, there's a particular mass of that 1 coulomb that will be deposited of the element in the electrolyte. So and then the statement of this is basically M is equals to ZQ. So basically what that means is that mass is proportional to the quantity of electricity passing through the electrolyte, and then the constant of proportionality is known as Z, and that Z is the electrochemical equivalent of a cell. And what that Z means is that is the mass of the element that is liberated by 1 coulomb of electricity. Now let me remind you that 1 Faraday is equals to 96,500 coulomb. And this 1 Faraday, it is the amount of electricity required to liberate an ion with a single positive or negative charge. So basically 1 Faraday of electricity liberates one unit charge. So whenever you have the magnitude of a charge on an ion to be 1, then it will require 1 Faraday. Whenever you have the magnitude of charge to be 2, it will require 2 Faraday. And this is known as the second law of electrolysis. So what that means is that whenever you have different elements in an electrolytic setup, so the relative amount of those elements, the relative masses deposited are inversely proportional to the charges on the elements of those things. So basically what that means is that whenever you have those different elements, the mass is inversely proportional to the charges. So and what that means is that 1 Faraday of electricity will if you have copper ion and you have hydrogen ion, just as we have in these two, they are competing, right? Now if you supply 1 Faraday, 1 Faraday will liberate one mole of this hydrogen ion, but it will require 2 Faraday to liberate 1 mole of this copper, because this copper has 2. So the charge on the ion of the element to be discharged will determine the amount of Faradays required to liberate it. So and then that is basically what electrolysis is about. So to summarize, we talked about the electrolytic cell and how electricity can pass through a circuit to liberate or to decompose it and liberate some ions, and those ions, they are dependent on the amount of electricity passing through, and those ions, the amount of charge carried by the ions will determine the relative amount of that element discharged. So thank you for watching.